Welcome to the first of the 2023 monthly ReproNim webinars. I get to, introduce myself as part of today's session. I'm Dave Kennedy, in addition to being the principal investigator of the ReproNim P41. I guess I traditionally describe my job at the University of Massachusetts Chan Medical School in sort of three phases. By morning, I'm a co-director of the CANDY, the Child and Adolescent Neurodevelopment Initiative program, a research program in child psychiatry and development at UMass. By afternoon, I run NITRIC, the Neuroimaging Informatics Tools and Resources Clearinghouse, a long-time federally funded clearinghouse of tools and software and data for brain imaging, broadly defined. And by night, I lead the distinguished group of folks who work on ReproNim, working on the issues of reproducibility and the like. So a lot of my coming into reproducibility had to do with trying to do studies from the old days in neuroimaging in children with autism and other developmental disabilities, and being pleased with ourselves with the things we invented and the data we acquired, but then being very displeased with how generalizable or informative these lovely observations that we're able to make were actually having in terms of being impactful for the patient populations that we're looking at. So a long history of things drew me to working on this sort of reproducibility problem, as we'll talk about today, and is sort of the core of what ReproNim is up to. In our webinar series, the first couple years of these, we had very sort of ReproNim centric presentations on the tools and resources that we're developing as part of ReproNim. We then went into a phase of more applied types of things where people would come and talk about the sort of real world studies that were ongoing and how issues of reproducibility or the tools of ReproNim were playing into those studies. With the beginning of the year, I wanted to take a pause and go back to sort of a high level ReproNim description as it's evolved over the years. So that's what we'll do a little bit today. And the rest of this semester goes off back to our sort of applied folks in the neuroimaging world, attacking different particular problems and using or not the methods that of reproducibility and engaging in the discussion of how reproducibility affects these various studies. So without further ado, I'm going to give a presentation. We'll see how long it actually lasts. A little bit of background about ReproNim. Not spending too much time, but reminding ourselves that everything is a problem and that everything matters, and therefore that's the scope of the kinds of things we need to pay attention to in our neuroimaging studies. And then we'll look at a couple of the emerging sort of Repro solutions and methods that are coming out of this center and the community as a whole. So by way of brief background, ReproNim is the Center for Reproducible Neuroimaging Computation. It's an NIBIB funded P41, which is a biomedical technology research center. And it's been initially, first phase was funded in April of 2016. We're in phase 2 now. And if the grant and work gods are bless us, we will also hopefully have another 5 years after that, as P41s ought to go. At its highest level, the objective of ReproNim is to enhance the reproducibility of the way neuroimaging research is performed and reported in the neuroimaging literature in order to extend the value of our national investment in neuroimaging research while making progress easier and more efficient for investigators. The premise of this work, even 5 years ago, was that the neuroimaging field is actually well suited, to do this. We have, established standards for the imaging that we perform and the data that we acquire. We have well-established tools for analyzing, these data, and we have, well-established in a network of, sort of federally funded repositories, that can, host, and retain, the data that we're acquiring as part of our, NIH-funded, studies. So in principle, all of the building blocks that would facilitate sort of complete transparency in the execution of neuroimaging research are in place. So in reality, it's not that neuroimaging literature can't be transparent, but rather it's not currently being practiced in a transparent fashion. And in general, you can ask all sorts of people why that's the case. But the summary, answer is it's still, sort of too hard, time consuming, not valued enough for people to go the extra mile to sort of, engage in the sort of complete transparency of their research, enterprise. So that kind of motivates that either ReproNim needs to be able to make it easier, which is one of our objectives, or increase the value of doing that, or instill in people that it's worth scientifically or ethically the extra effort that's necessary to get towards transparency. So those are sort of the three ways that trying to move the needle in terms of how transparent, how re-executable, how generalizable our current neuroimaging literature can be. And just by way of thinking about this again a little bit more specifically, I pulled out a recent paper. It was published in December of 2022 that is just looking at some sort of neuroimaging finding in kids with autism. And again, it doesn't really matter so much what the paper is. It's sort of just a random, most recent example I could find. But again, lovely little paper published in Psychiatry Research that looked at publicly available data in autism and made a bunch of observations. Compared with typical development group, the autism spectrum disorder group showed increased gray matter volume and density in a handful of anatomic regions. In the ASD group, the social interaction was negatively correlated with some of the gray matter densities in certain regions. The communication was positively correlated with some regions. Repetitive behavior was correlated positively and negatively with some regions. So fine, lovely paper, a good number of subjects and publicly available data, a bunch of findings there. Theoretically, I would like to believe these findings. And again, I'm not going to pick on this paper per se, but again, that paper gets published, has a bunch of observations, and you'd like to trust and believe that these sort of high-level observations that are reported here are true. So we'd like to believe that these observations are related to subjects with ASD and not particularly specific to a particular subselection of subjects. We'd like to believe that the observations are related to the thalamus and the hippocampus and the different anatomic regions, and not some sort of tool-specific nuance of those particular regions. We'd like to believe that the named behaviors, social interactions, communications, et cetera, are representative of those behaviors and not some specific assessment-specific artifact of the measurement of those. We'd like to believe that the correct statistical model is being used and we're not missing some important additional observations or covariates or interactions. And so in summary, we'd like to believe that those observations and reported brain behavior relationships are true about the brain and that behavior, and not something about the way we're acquiring and making the measurements, imaging and clinically, or doing the analysis. Because in order to grasp those high-level observations, it's very hard to keep with that all these other sort of caveats about those observations. We just like to believe that the brain is correlated with these things, or the different groups have these different differences, and not have to worry about exactly the way those measurements were observed. So that's what we'd like to believe. And again, various papers, all the details, at a human readable way are always, provided in most, reasonable publications. But, very often the details that, could, relate to the alternative, statistical models, or the ways behaviors are made, or the way anatomic is analyzed, or the details of subject, relative to the greater population are not always resolved. But so that's the kind of thing, how much do we trust, that, observations that's in a particular, publication? If you pay attention to the literature too much, you can get a little anxious and nervous about trusting anything you read in the literature. The popular press and the scientific press is full of publications which call into question virtually everything about neuroimaging specifically. Our software has bugs, dead fish have activation, and all functional MRI is movement correlated motion, et cetera, et cetera. So there's lots of cause for concern at sort of a high level about the neuroimaging literature. but that's not really specific, to neuroimaging. Dig further into literature, and lots of science as a whole, is being inundated with things that go wrong, and trusting and not verifying, and not proper evaluation and testing of code, and problematic, complex analysis models that aren't properly vetted, and things of that sort. So again, if you look at these kinds of admonitions, why do we believe anything that gets published? So we're concerned about that. And again, it's easy if you listen to ReproNim mantras and things like that. We're quite concerned that much of what is published is not potentially exactly true. Up to 80% of research funding is wasted. Only 20% of publications are replicable. Most research is false, et cetera, et cetera. So again, we're inundated a lot with all the things that can go wrong in our approach to understanding and performing science as a whole. This is a slide I borrowed from J.B. Pauline that laments some of the things that Richard Horton, the editor-in-chief at The Lancet, lamented about in 2015, which again is important for us to keep in mind. In his article, there, he was concerned that much of the scientific literature, is simply untrue. The quest for the compelling story, too often sculpt data to fit the theory or retrofit hypotheses, and our love of significance, pollutes the literature with many a statistical fairy tale, and we reject important confirmations. So again, on the one hand, we read papers, we write papers, and we try to do our work as best as possible, but again, we just get hit, sort of constantly with all these concerns and sort of grains of salt, and just concerns that we're not coming up with the right things, or publishing the right things, or doing things in a way that is appropriate for the current state of the art. And the final sort of motivational thing I keep coming back to in the mental health area, a quote from Tom Insel back in 2012, who was the head of the National Institute of Mental Health, which lamented the profusion. Lots of people find statistically significant things, but most of these are minimally differentiating. Many of them are only approximately able to be replicated, and many of these are done in ways that neither confirm nor in ways that can't be confirmed or refuted. And so therefore the publications that we end up, the findings we end up with, they don't really move science forward in a proper way. So again, all of these things are driving at any publication that comes out. Any publication you read makes you concerned about how much do we trust these, given all the sort of background concerns and grains of salt and negative things that are sort of said about the scientific literature as a whole. So over the course of ReproNim's attempt to try to make some progress in this general area, I'm going to introduce things in terms of reproisms that sort of provide a little bit of the state of our thinking about some of these things. Reproism number one I'm using here is that the cornerstone of reproducible research is transparency. And transparency is achieved through annotating and sharing with others through publication precisely what operations were performed and on what data they were performed, and doing that in a fashion that could potentially be re-executed by someone in an attempt to replicate and ultimately generalize that original finding. So that's really at the driving point of trying to get to reproducible research through transparency. We have to think for a moment about sort of reproduce what, and again, this has a couple of levels, and we'll look at this a couple different ways. But on the one hand, we could reproduce in a particular individual publication. We could be looking at reproducing a specific result in that publication. So if in a paper, I write that the free surfer volume of the hippocampus is 203 cubic millimeters larger in the boys than the girls at some statistical threshold, it would be nice to someone other than me be able to re-execute that particular observation and find something pretty darn similar to that on the same data, the same approach that I did. And that's good, and that's important. But ultimately, what we really want to do is reproduce or generalize the claim And we do that by looking at different data, different approaches that are related to the volumes of the hippocampi in boys and girls. So we'd like to get to the point where we can make the generalized claim that hippocampi are larger in boys than in girls, and be independent of exactly which MRI scans I'm using of boys and girls and which tool I'm using for observing that. So again, generalizing, reproducing at the publication level, we talk about as reexecutability, and reproducibility at the claim level, we sort of talk about as generalizability. And again, we want to get to this latter observation, that is broad and general, as opposed to the specific details from a particular finding that could be sensitive to which boys and which girls and which software and which statistical analysis. The problem, of course, and other presentations we've done remind us that when it comes to examining the reexecution or the generalizability of any observation and publication, it turns out that everything matters. I'm not going to spend too much time in this. This is part of other webinars and lectures that we do routinely, but exactly what operating system you're using for your analysis matters. Even the exact same software, exact same release on different execution platforms do not necessarily generate exactly the same metrics. How much data you have matters. Small effect sizes, care if you have, small ends or medium ends or large ends. And this little graphic here illustrates, that example, looking at, the hippocampus volume, the sex effect, the boys versus girls in hippocampal volume, back in 2005, where there was 325 subjects from the NIH pediatric developmental database. You could look at that data and you might or might not, didn't find a significant volumetric difference between boys and girls. Fast forward into 2011, when PING, the pediatric imaging, neurocognition, and genetics, data becomes available. We're up to an N of about 1,500 or so. And looking at that sort of same observation, we begin to see, that this original broad observation is resolving a little bit better. And you do see sort of a significant difference between, boy and girl volumes of the hippocampal volume estimates. And then as more data becomes, abide and other things, that observation stabilizes. The point sort of being here, it's a fairly small effect that just because you don't see it in 325 doesn't mean it's not there. It just means your sensitivity to detecting an effect of that size was not there. So how much data you have relative to the effect size obviously matters about how generalizable or reobservable a particular finding is. Now, this isn't rocket science or even new. We know this from statistical first principles, but sometimes again we get distracted by hoping for big effect sizes, and when we see things or don't see things, forgetting about sort of false positives and false negatives that happen when we're ultimately using relatively underpowered studies in general. Exactly what tool one uses matters. Again, if we talk about any particular, in this case, anatomic observation, in this specific case, we're looking at the left caudal anterior cingulate volume. There are many tools that can observe that. In this little example, we're looking at ants and FreeSurfer, and specifically two versions of FreeSurfer, and looking at in the same pile of subjects, from the Abide, data set. Within FreeSurfer, the different versions, the measurements of this particular region, are pretty well correlated. But when you use different tools to look at the same region, you see good correlation between the observations. But because there is so much data here, that good and significant, correlation is not, still has a, it's not unity, and there's a good, sort of off axis, it's not a unity, good off axis, to that. So there's a good bit of unexplained variance, between the two different methods. So again, one has to be careful that generalizing across tools to the extent that they're making a similar measurement or not, and depending on exactly how similar that is, one can get different sensitivities to different types of observations. So again, tool selection matters in terms of what you might or might not find in a particular study. Exactly what statistical model you use matters. This is just again an example from the ping data, about 1,200 subjects. Again, looking at this sort of sex effect, boys versus girls, and the volume of the hippocampus. This data includes, amongst other things, sort of a bunch of different covariates that one could use: age, site, socioeconomic status, total brain volume, genetic ancestry factor, etc. So one could imagine many different models that use, any or all of these different covariates, and lo and behold, you see that exactly what model you use can, affect the effect size, which you're seeing, on the x-axis here, and the magnitude, the goodness of fit of that model, on this y-axis here. So again, there's some models which show a large effect size, but don't have a super good goodness of fit. It turns out that these are all the models that don't have the brain volume as a covariate. Now it makes perfect sense, of course, that total brain volume has a sex component to it, so that when you take that total brain volume factor out, you get a number of models that have a much larger goodness of fit, because we're doing a better job fitting the data. But we've removed a lot of the potential effect with the total brain volume, and we're left with this little cluster of models that are better fit to the data. But some of these are significant, and some of these aren't, even in the largish ping data set. So again, we're not dwelling on the background to this, but the point being that exactly what model is being used, exactly what covariates you have, exactly how well these covariates describe the magnitude of the effect that you're observing, can be variable and can be sources of why things do and don't generalize quite as simply as one would hope. So working my way to ReproNim 2, since everything matters, and we're after a transparent publication, what we're going to claim a transparent publication is a publication that can be re-executed. And that's something we've come to call the ReproPub in the ReproNim world. So I sort of talked a little bit through this kind of concept already, but the point that we're trying to get at here is an original publication is based on some data and some analysis approach and generates some particular result. Re-execution of that is simply the fact that if you had access to the exact same data and you had access to that exact same analysis, well, we expect that someone could generate that exact same result. And so that I can guarantee you, and again, anything I complain about the world or the community doing, I've been in this long enough that I've done every bad thing known to humankind. And so I've done all these things. I can't go back to any of my papers from 2005 or something and find the data, or find the exact same analytic routine I did, or find the exact same computational system and re-execute those observations. It's just not practical in some sense to do that, or it wasn't practical in that day and age. But again, we got to get to the way that we're archiving the data and describing our analytic ways so that re-execution can persist going forward in time. The importance of that re-execution is because when we get to thinking about generalizability, what that means is how sensitive is that result to the exact details of the data. If I use the exact same data but use a similar analysis, how sensitive is my finding to exactly the details of that analytic approach. Similarly, if I keep that exact same analytic approach and use similar or change the data in some way, how sensitive is my result to the details of that data that went into the observation. So by being able to do the exact same thing and prove that you're in the exact same analytic place, you can then systematically tweak the data or tweak the approach and really understand much better how sensitive the observations are to the details of both of these aspects of the analysis. And so a real truism that we're trying to get at is, if we had a conclusion, a claim that we would want is, if we had similar data to what I had and a similar analysis, we should get a similar result for something that sort of holds as true relative to that type of observation and that type of population. So that's what we're after, is really results that we can document their generalization of. But in order to get to that place where we can systematically look at the generalization, we need to start from a basis where we have re-execution of the original observations, so that generalizability can be systematically observed. And so that's why the ReproPub has become sort of the hallmark of where we need our publications to be, so that each publication can feed into its assessment of its generalizability and its relationship to other observations. So the ReproPub is a publication that looks an awful lot like, from the words point of view, like a publication you would write otherwise. But a ReproPub somehow has to get the reader to have access to or potential access to the exact data that went into that publication, the exact workflow that went into that specification, the exact execution environment that was included, and that complete set of results that were the basis for the observations. So exactly how this can be accomplished, can vary, but right now we very often don't have data associated. We very sometimes have low-level descriptions of the workflow. Very rarely do we have execution environments specified, and very rarely can one get to the complete raw results of a publication. So we really need to evolve the ability for literature writers to be able to include all of these things precisely, not as part of the thing that humans read, but at least attached to a publication, so that each of those elements could be accessed appropriately, especially from the data point of view, so that someone other than the author could re-execute and get that same answer, and therefore change themselves, then change the data or change the execution or workflow specifications. So ultimately, what this is trying to get to, the complete description, i.e. the provenance of the data, workflow, execution environment, and results being attached to the publication. I have a couple examples of these that we've talked about in other occasions, and I refer you all to the prior webinars on this kind of thing. The early example of the simple workflow that just used a small set of data from Nitric, used a fairly simple FSL based brain volume extractions, used a Docker containerized environment, and posted the results into a public location. Really exemplifies that it's not technically a challenge to write a publication that has connections to all of those precisely re-executable elements. And so again, it's sort of documentably re-executable, because anyone could acquire that and anyone could confirm that they got the same answers or different answers if they did something different than what we did. More interesting version of this looks at a publication that looked at a number of hypotheses related to IQ and brain structures. This is one of the particular observations about corpus callosum volume and brain volume. And the original publication was done many years ago in 2011, but in the re-executable version of that, we get similar data and similar looking results. But in contrast to the PDF of a picture that you might have in the current publication, the re-executable publication, the ReproPub version of this, every single data point, in a representation such as this, knows, who that subject was and what its demographics is, through the linked data mechanisms that we're trying to generate. That data point knows who generated it, knows what MRI scan it came from, knows where that scan is archived, knows what workflow generated it, what software and hardware it was run on, and knows where that type of measurement fits, in the grand scheme of measures, that one can make, sort of in the ontological space of brain observations. And so in this case, that particular workflow is associated with a particular, container that lives at a particular ReproNim container store. The results, generated, live in a particular data store, Repro Lake, and so all this can be attached to each other. So one can go back and then change the data or change the processing and see how well that observation, this particular correlation, generalizes in different contexts, which is very hard to do from the original publication because of the details of the analysis not being completely specified or completely accessible to the end reader. So that brings us up to Reproism number 3, that in order to maximize transparency and in order to reduce the barriers to transparency, we really need to plan version control, annotate, use standards, and publish or share otherwise, everything about, the research, enterprise, the publication, enterprise. And this really has led to something we refer to as, the 5 steps to more reproducible neuroimaging research, which, sort of walks through this, and we'll see a little bit of that, as we go forward, here. So just a bit of background to these, planning everything. So again, the goal is, annotating transparently, precisely what operations on what data. Ask many data analysts. Often they run into trouble when the investigator or the PI comes back and asks for something sort of after the fact, after the data was acquired. Then they come and tell you what the hypotheses were and what they want you to see. And when they haven't planned it in advance, invariably the analyst comes back and say, oh, but do we have blah or blah? And the answer is often, oh no, we didn't do that. So again, planning everything is hugely important to avoid trying to pigeonhole the data analysis into something that doesn't really match if you try to wait till later. Version control for everything is important. Again, when we think about version control, we're most used to hearing about that in terms of software, and GitHub and version controlling of software development. But version control applies to everything, to data itself, to the scripts that we're using, to the software, to the containers, protocols, etc. We need to document versions of things exactly because our first version of what we think we're going to do almost never ends up being what we did in the end. And again, unless we precisely understand how the plan, how the analysis evolved, and when it changed and why it changed, and where different observations fall relative to when things changed, we don't really have a good sense, of how the data and how the analysis and how the operating systems, relate to the pile of data, that's generated as part of the analysis. Annotation is important, so that when we do share the data, others can understand and reuse it, more easily. One of the large barriers we run into in data sharing all the time is, oh, it's too hard to explain to people after the fact, exactly what the data is, or what it means, or what the variables were. And so, people, I don't want to share my data because people are just going to ask me about that, and then I have to figure all this out, and blah, blah, blah. That's too hard, it's too time consuming. The goal of annotation, is at the beginning, at the design of the study, make sure that we create the annotations for all the data elements that we're acquiring. And so you do that once, and you do it at a point in time when it's easier for the experimenter to do, and do that once so that anyone else can understand and reuse that more easily, and then no longer becomes a burden later on when you share any of the elements, what the results are, what the variables are, and again, it's more self-describing in terms of use, and it lowers the barrier to you're sharing the data because you don't have to answer a million questions about it. And the next level is using standards. And so again, standards are important, again, because it lowers the barrier when you share things. If you share things that are standards, others can more easily understand and access what those are, and requires the user to do less description and hand-holding about what it is they're sharing. And again, we know of our lovely standards for imaging, DICOM and NIFTY and BIDS and things like that. But there's also standards for execution of data analysis and things like that, through things like containers. So that others can more easily do exactly what you did. So in this case, we're using sort of containerized, computational environments as a standard, way to execute, the analyses, that we're talking about. And then publishing in a broad sense, or sharing, sort of everything appropriately, so that the at the worst case, future you can find exactly what you did, and then when you do, come to share, others can more easily access, the data plans, the raw data, the derived results, the workflows, etc. Now, again, this can be published in peer review. It can be published in preprint servers. It could be published in even Google Docs and Google Drives. The point is sharing in a way that someone can find the plan, someone can find the workflows and processing scripts and find the containers and appropriately find the data, you in the future or others, that want to come back and look at the observations, that you made. So taking those kind of 5 steps across, sort of the standard analysis, workflow, we have, a given, study. It's been planned. There's some data acquisition, elements to it. There's some data analytics, there's some statistical processing to it, and then there's the publication, aspect, to it. So all these sort of things happen routinely in the course of a generalized, analysis workflow, and each of these stages of analysis, really want to have these sort of 5-step principles applied to that. And so by that, we think of these, stages and the steps in the research process being design, data collection, image processing, statistics, and publication, and the best practice 5 steps concepts, that we presented in terms of plan and version control and annotate and standards and archive, publish. We really want to be able to fill in sort of this whole matrix so that, as people, do their particular imaging studies, we can achieve, planning, version, description, standards, and archival across each of those different stages. And so again, a lot of the efforts in ReproNim therefore have come to trying to fill in elements of this sort of this grid. And then I'm not going to speak too much about the specific tools, but again, the point is we want to make sure the community is armed with either ReproNim or other ways to accomplish these best practices across all the steps in the research process. So we have tools that deal a lot with version control for data, data lad. We have standards for execution and data description, the neuroimaging data model, and containers, supporting containers generally, and NeuroDocker as a specific container builder. Encouraging pre-registration as part of the planning stage, encouraging version control across all the stages with Git and GitHub types of things, and sharing the metadata and the provenance data through sort of the archival and publications into the ReproProns and Repro Lakes, the metadata stores that can retain locally or publicly these types of information across the spectrum of steps and best practices. So I'm not going to go into the details of these per se. Either older webinars or future webinars will help highlight these various tools and their applications. But again, that's kind of at a high level, the space that we're trying to make sure that users have solutions that solve the steps and the best practice stages that we want covered. And so part of that Reproism 4 here is that metadata and provenance are important, and we need to treat them appropriately. And I guess by example, I look at this figure here and kind of remind ourselves that traditionally, we often think about data analysis. You acquire some data from your scanner. You may save that data, locally, your BIDS, data representations. You may do some analysis and generate some results, and you save those results locally. You do some analysis and generate your statistics, and then you go off and publish that, and maybe you're a good person and you do share that data eventually with one of the public repositories. So historically, we've often lived in this sort of data-centric world. The images, your DICOMs, your BIDS, your NIFTIs are kind of the key results. Various stores that address those. The element of transparency and metadata, though, and provenance really has it every time we go through this analysis step. That analysis lives in some compute environment. That analysis is generating results, and our data has metadata associated with it. We really need to add this sort of upper layer here. That so each stage of analysis generates metadata and provenance. Each stage of computation generates metadata and provenance. So that in addition to the files that we're traditionally used to paying attention to. We also have to pay attention and retain the metadata and provenance of each of the steps, that are following along, so that the description of a result file is complete, because of its association with the metadata of the data and the provenance of the processing. That result, therefore, becomes more completely described in ways that are sort of attached together through the linked data models that we have. So that thinking of this sort of complete, more up-to-date result is not just the files we generate, but also the metadata and provenance associated with that. So then when you go and write your paper and share your data you can link, yes, to the data wherever it lives. You can link to the provenance and the analysis. You can link to the metadata of the resultant analyses, so that when you go ahead and publish this, yes, you can publish your files and things to the traditional public repositories, but you can also publish this metadata and provenance data through things like the Repro Lake that we've talked about, and others have talked about. Look, in the big picture, we're just trying to make sure that this metadata and provenance are really as easy to hold on to in the process of your routine processing, and as easy to share and connect to the publication as traditionally we think about of some of the shared imaging files that go along with studies. So overall, it's not easy. It takes a village. It takes a Repro village. A number of things need to be done, and ReproNim's engaged in supporting the community of investigators and trying to enhance training across individuals to both in the specific tools and the concepts that embrace this richer landscape. ReproNim itself provides many basic materials regarding fair data, computational basics, reproducible workflows and statistical tools. We also have, many of you may be aware of the ReproNim INCF training fellowships, sort of year-long opportunities to try to train trainers who can help train the community. We've been part of a number of separately funded courses, specifically the ReproNim ABCD course for reproducible analysis, and Repro Rehab, our old and ongoing efforts to sort of support ongoing coursework. And of course, you listening to this as part of the monthly webinar is another of our sort of core training elements. The next concept, though, is it's great to teach individuals each of these different things, but what we've discovered is often individuals go back to their home institutions and can sometimes have trouble really integrating what they've learned into the ecosystem that they run into in their own labs or in their own centers. And so this next sort of phase of our work is really beginning to try to identify Repro centers, sort of at a center-wide, from a center director down through all of the PIs and all of the folks working on those PIs teams, getting a center, to adopt, these concepts, so that it makes it easier for the individual investigators and the individual data analysts and the individual and sort of software developers, to buy into that center, point of view. And so again, in addition to training individuals, we're really trying to identify and convert centers in order to really embrace sort of these 5 steps in the study design and pre-registration, data collection, bids and who to come, and sort of bids, representations, data management, data lad, and containerized technology, data analytics support through ReproNim data management systems, and dissemination through things like the Repro Lake and other things. So trying to get sort of full system buy-in, so from the center director on down, to really give people sort of complete community so that they can embrace this more broadly. And so again, that's to some extent one of our sort of newer ways of trying to not just train individuals, but to convert labs or centers at a whole from the scanner on up to the publication, to be embracing these kinds of things, so that individuals aren't quite so on their own island, trying to solve these specific problems. And many of you may have seen last month's ReproNim webinar from Keith Bush at the Brain Imaging Research Center, who really talked about a personal lab's effort, to go through this conversion into the more reproducible methodology. And in his paper that's annotated here, really looks at sort of the cost and benefit ratios of doing each of these sort of various steps that are important. And again, so I highly encourage sort of looking at that video and that paper and trying to relive some of the barriers and benefits of these kinds of conversions. So that's kind of my state of the ReproNim for the time being. We went through a number of these Repro-isms that I think are important for us, to keep in mind and to strive towards. And so at this point in time, I will thank all of the people from the ReproNim team, that many of them listed here, probably missing one or two, but and all the folks who support that. And I guess I will turn things over to questions.
It was very good. I guess one question, Dave, is the something that I'm always a bit struggling with is how much we try to have tools or methods that are ubiquitous and generalized and general enough to apply to a very large number of things, or how much are we trying to maybe take one scientific field such as child psychiatry and maybe like a specifically HDHD or specifically whatever, and try to apply those principles in that specific field with those constraints of that field, and see how we can then move to the next field or let someone else take over for that next field. And just like, I've a little bit always had the feeling that maybe the kind of the way we started with a number of things are quite kind of a very general. And I think for some of the tools that's actually good and right way. However, the kind of a specific impact on applications and application fields, it's sometimes a bit slow or a bit less, a bit diffuse or something like that. So I was, and maybe my question is not very well formulated, but it's just like maybe we're relaying more like a feeling than an actual question. But it's more like how much should we more like try to improve some specific things and not just put some blind eyes on other things, and how much we're trying to lay ground on like a very large ground, or a very general principles ground. Maybe it's a discussion more than
I think I know what you mean, and have faced some of the same dilemma as well. So again, there's at least two axes that we worry about, one of which is sort of the clinical domain. So again, in my little work, I often tend towards autism and things like that. On the other hand, some of our CPs and SPs work on Parkinson's disease and other important things. And so one question I have is, to what extent is our stuff independent of that sort of clinical domain? And then the other big axis is all of these things have different nuances and flavors when we talk about structural analysis versus task function or resting state and things like that. And again, I kind of personally pigeonhole the structural workflow as sort of lower hanging, easier, or at least more constrained bit of workflow, that if we could focus, I'm less concerned about if it's Parkinson's or if it's autism, but I'm more concerned that if it's structure, volumetrics or things like that versus functional MRI or resting state types of things. So I don't have an answer to that, but again, I think we've kind of gravitated towards solving some the structural pipelines a little bit more so than diffusion or resting state or task types of things, with the hope that that would generalize across application areas a little bit more broadly, and then leave some of the other acquisition domains to further work. And again, if we could fix the volumetric literature for any disorder, that would be an important thing. And then second, people or phases or approaches could go to those other modalities, but that's just my urge. And again, it's a good and important question, and we sometimes dilute our effort because we spread it across all these things a little bit willy-nilly. Mary, yeah, so that's a good question. Let's keep that in mind again, as we need to keep that in mind as we keep pushing what a center is and what it can accomplish, and what the next phases of this enterprise are.
This is sort of
Mary Ann's hand. Yep.
It's a high level generic question, and probably not answerable, but I was very struck by the way you opened, where you said, I picked a random paper, right? I picked a random paper in neuroimaging. And, people have been at this for a while. I mean, the problems in neuroimaging and science in general have been brought up repeatedly, and tools and other practices are there. And I wonder if there's positive news when you pick up, I mean, to me, you picked a random paper and I'm like, oh, good, they use public data, right? Which was already something that had not happened before. And so, I would expect that we would start to by now seeing impact of what recommended best practices are, even if it's not a full ReproNim reusable paper in neuroimaging, because there's been so much emphasis and effort put on this. Can you make any comments about that?
First of all, to agree with that assessment, I think, is part of what we need to keep continuously an eye on. Again, we're not going to suddenly go ding, we've succeeded. We're going to marginally have papers that use more. I mean, and the public data on the one hand is nice, on the other hand is kind of not our end goal. The people who put Abide out there did that long ago, and not with our influence. Our influence will be when some random new little study happens to go ahead and put that data in Open Neuro or share it somewhere. Our significance will be when it explicitly uses some sort of container or has some sort of pointer to the execution environment and the workflow that was run on it. Our success will be when these other elements of that are being adopted. And so the public data is good because it's accessible, but is only one part of that. So yes, I mean, I think we need to continuously monitor as each of these different elements of things get adopted, and take advantage of sort of documenting that uptake as well.
Could we generate just a random sample of neuroimaging literature, structural, let's say, and start to score just as a metric that one has to see how these practices are promulgating? And then, there's like 5 or 6 things.
Yes, and for example, we did something like that from Steve, Hodge, and Christian, and some of our group did sort of a snapshot of the 2017 autism structural literature. Looked at sort of 50 structural publications and assessed to what extent are the software, containers, operating system data, and things like that available, more as a sort of a snapshot of that history in terms of how things were in the past. And that is kind of a potential baseline that, again, can we move that, those metrics, going forward? If I took, the last 50 autism structural papers, have we made any progress?
Yeah,
so again, I think that would exactly be right.
And I think doing that just periodically, even in a domain, would be a really positive message to show, or negative, right? But
Yeah.
one should know, right? One should know. So I think that's great. I'd be happy to help with that.
Yeah, that's great. And again, we happen to do a little bit of the autism sub-literature. I know JB and the Montreal folks, have interest in the Parkinson's, sub-literatures. And again, that could be, and both of those have good domain data hosts, PPMI and Abide and things like that. So the barrier should be a little bit lower in those domains, but how well are we doing? And again, it could be a reflection on ReproNim, or it could just be a reflection that this kinds of social change takes a little bit longer than we or our granting
I
evaluators like.
Yeah, but I think it's time for the field to start producing these type of things so that the state of the field can be assessed.
And part of doing that was, to be able to point to some good papers and to point to some bad papers, and not make fun of people, but to be able to highlight, really, things that shouldn't be acceptable and things that reviewers shouldn't be letting get through the review process if you don't
I
say
think
certain
it's
things.
very important actually to do that. It'd be very helpful.
Yep.
Okay, but nice talk.
Yeah, and Austin provided an answer about pre-registration rising fast, so that's good. Thank you, Austin, for that. And again, we know that the mandates from the NIH are going to start impacting this as well. Yeah, even more.
Well, at least of making the data available. And the question is, again, how much more standards based? So everybody's going to be looking for this, and we're kind of in a good position, I think, to do that for this very, small corner of the world, so to speak.
Yep. Okay, I realize we're at the end of our hour.